All right, this is Mr. Ware. Going to be taking a look at these notes today. It's 431, day one. It's the surface area of spheres. So we're looking at, this is a sphere. So when we have a sphere, we have the radius, and the radius can go any direction to the outside. It's from the center of the sphere, and it goes and touches the outside. But instead of just like left, right, up, down, whatever, anywhere around the circle, you have to remember it's anywhere in 3D. It can come towards you, away from you, at some weird angle. So as long as we have that radius, we know what's going on. The chord is still going to be like a circle, but it's going to be connecting a couple points there on the, or no, it just connects any 2 points on the sphere. And then our diameter is going to go through the center all the way, connecting 2 points. And again, the diameter, if you cut it in half, it's still going to be the radius. The tangent is going to touch in one place. So this is our formula for surface area of a sphere. It's 4 circles, because pi r squared would be the area of a circle. People already did all of the math to get you to this place, so you only really have to use this formula. It's 4 pi r squared. So if we know this one, you're going to take 7.1, you're going to square it, and you're going to multiply that by 4 pi. On this one, the whole diameter is 22, the radius is going to be 11, so you take 11 squared times pi and then multiply that by 4. That's going to give you your surface area. When we have the intersection of a plane and a sphere, this is kind of an important thing. There's a great circle. The great circle is the one that goes all the way around, and it would contain the center of it. So when you think about like a globe, because a globe is a pretty obvious sphere, the equator is a great circle, and all the lines of longitude are great circles. They go from pole to pole, all right? But the lines of latitude, other than the equator, those are not great circles. They would not go through the center, okay? They're just circles around on that sphere. So if we cut the sphere in half, we end up with a hemisphere. So the hemisphere is going to look like this. It's funny because if we think of the sphere, the surface area of the sphere is 4 pi r squared. So half of that would be 2 pi r squared. So we're like, oh, it's just 2 pi r squared. But when we cut it in half, we have that great circle on the bottom, and it has that same radius. So that's another pi r squared. So it seems like the hemisphere would be closer to half, but because we still have that bottom section to add on to it, it's 3 pi r squared. So the sphere is 4 pi r squared, the hemisphere is 3 pi r squared. Okay, find the surface area of each figure, round to the nearest tenth if necessary. A sphere where the circumference is 16.2 pi, we would divide by pi, we would divide by 2, that would be 8.1 for the radius. So we do 8.1 squared, multiply that by pi, multiply that by 4. If it's a hemisphere and the area of the great circle is 94 square millimeters, that is pi r squared. So we just need to multiply this by 3. We don't need to do anything crazy. And on this one, the hemisphere, the circumference of the great circle is 36 pi. Remember, it's 2 times pi times the radius. So if we divide this by 2 and take out the pi, my radius is 18. So we would do 18 squared times pi. And then because this is a hemisphere this time, we would multiply that by 3. This should take you through the notes. And then your assignment, I haven't decided if I'm going to try to make it a Delta Math or a paper assignment, but we'll cross that bridge when we come to it. This is, again, your work and your notes for Friday.